Welcome to another video. So today we are going to be proving. So proving, it's somehow a big problem for some students. So in this video I want us to dive into how to prove a cyclic quad. So when proving a cyclic quad, the first important thing that we have to know is only two things. You're going to be using the properties of a cyclic quad. Okay, here's what we know. The opposite angles in a cyclic quad are supplementary. Let me write it down because I don't want to erase it. I want us to use this even when we're going to attempt this problem. Supplementary, meaning that the opposite angles inside of a cyclic quad add up to 180 degrees, and the exterior angle of a cyclic quad is equal to the interior opposite angle. Alright, these two things, or the two properties that we know when solving cyclic quads or even Euclidean regarding cyclic quads, this is what we know. So when we were going to be proving this, we have to apply this. Now in the proving, I usually recommend this. Use this one, the second method, which is the exterior angle of a cyclic quad is equal to the interior opposite angle. The reason why, it's because it's much simple, because it's equal to what is inside of the cyclic quad. Now I'm not saying the first one you don't have to use it. No, you can. Now the problem is you're gonna have to add up some stuff, and you know how time is in the examination. Everyone is panicking. So that's why I recommend that use the second method, because in that way, if you find, for example, I'm just giving an example, I haven't read the question, I haven't done it before. Let's say they say this is 32. The only thing that you have to do is to just make sure that maybe D2 is 32. Because if you find out that this is 32 and this is 32, then you've proved it. Now if you're using the supplementary, this means you'd have to add up some stuff in order to find F2, which is going to take you a long time, but you can do it, right? If you feel confident that you will have enough time. I'm just giving a tip. Okay, now let's attempt the problem. Now it states in this question, it's quite simple, quite short, straight to the point. It says in the diagram, ABCF is a cyclic quad. AB is a tangent to circle BCD at B, which is, yeah. Prove that CDEF is a cyclic quad. CDEF is a cyclic quad. So that is what we are proving. Okay, now so that everyone can keep to note, I'm going to draw an imaginary circle, right? Since a cyclic quad, all of its 4 points touch the circumference of the circle. So this is my imaginary circle. It won't be nice, guys. Please don't judge. Now, after doing that, I'm going to try to attempt it. I'm not going to try, I'm doing it. So, I don't have a number, but it's fine. The first thing that I would honestly do is to do what? Let's use the second one. The exterior angle of a cyclic quad is equal to the interior opposite angle. So how can I equate? Can I remove this because it's disturbing me a little bit? How can I make F1 equal to D2? They have to have something in common. Okay. Now the first thing that I notice is we have a cyclic quad. We have a cyclic quad which is BCFA. Now this is the cyclic quad that I'm talking about. So in the cyclic quad, I know that angle F1 is going to be equals to 180 degrees minus angle B1. How did I find it? Well, you know that opposite angles of a cyclic quad. Alright, so basically angle B1 plus angle F1 is equals to 180 degrees. The reason opposite angles in a cyclic quad, opposite angles of a cyclic quad are supplementary. Okay, now ever since I found this F1, angle F1, now let's look at D2. How can we relate angle D2? Okay, now for angle D2, we know that they said AB is a tangent, AB, and we know that we have angle B1. How about we use tan quad? So we're going to have tan, let me use a different color here, we're just going to say tan quad alternate back home, meaning that D2 is equals to angle B1. So angle D2 is equals D1, sorry, angle D1 is equals to angle B1. Okay, why tan quad? Tan quad alternate back home. Now since we know that, we can use sum of angles in a straight line and say angle D1 plus angle D2 is equals to 180 degrees. Why sum of angles on a straight line? That's a long. Alright, now we can say angle D2 is equals to 180 degrees minus angle D1, angle D1, of which angle D1 is equals to what? Angle D1 is equals to angle B1. So this means angle D2 is basically 180 degrees minus angle B1, of which angle F1 is equals to 180 degrees minus angle B1. So we can therefore say angle D2 is equals to angle F1. Why? Converse exterior angle of a cyclic quad are equal. Right? You can write it perfectly the way that I did. The exterior angle of a cyclic quad is equal to the opposite interior angle of the cyclic quad. And just like that, we proved that CDEF is a cyclic quad. You see why I said that using the second one is going to be much easier. Now let's say you use the first one, you're going to do a lot of calculations. Like I said, you're going to firstly have to find F1, which F1 you could find it since you have like F2, F1 you have it, so it's 180 minus B1, and then you would do angles on a straight line and you would find angle B1, and here since it's equals to 180 degrees minus B1, then your answer will be like that. So even if you did the second method, it would take you probably another 1 minute or 2 minutes. I won't do it in this video because, like I said, I'm just trying to emphasize my point of using the second method. But the first method, you just carry on like that. Well guys, I think we've reached the end of this one. I'll see you guys in another one.